Hi everyone. In this class, we'll discuss what is IP address, and after then we discuss about subnetting. The IP address is the assigning the end host. So here we have two types of IP addresses: private and public. Private IP address is free of cost, and public IP addresses we should have to buy from INA. Now, IP address range starts from 0 to 127 class A, and class B is 128 to 191, and class C is 192 to 223, and class D is multi-casting IP address that is start from 224 to 239, and class E nowadays we are not using this IP address, wastage of this IP address. So the range is from 240 to 247. Now this is the IP address range. Now move to the what is subnetting. Here subnetting is a process. So it's subnetting is a process dividing a single network into multiple smaller networks. It will be convert it one network into multiple network, converting host bits into network bits, and we will convert that net host bits into network bits. That is nothing but and zeros into one. And subnetting involves dividing a large IP network into smaller, more manageable subnetworks, and optimizing IP address allocation. It means we are giving that IP address to end host. So mainly subnetting help in minimizing the wastage of IP address. It is a technique dividing large complex network into multiple subnetwork and dividing big network into smaller network to reduce the wastage of IP address. So it is here main concept is subnetting the reduce the wastage of IP address. And subnetting mainly here two performance, we can do two ways to we can implement the subnetting. So one is FLSM and one is VLSM. FLSM is nothing but to uh, fixed length subnet mask. Here you can check here 50 50 HR department 50, and account department 50, and sales department 50, admin department 50. Everywhere we are having one IP address range. That IP address range we have 254 IP addresses. In that IP addresses will share to each and every equally. So that is fixed length subnetting. Now move to the VLSM, variable length subnet mask. Here HR department is required 20 host, and is account department 20, HR department 10, and sales department 100, and admin department 50. So variably we are giving the IP addresses to host for that. Now the main purpose of subnetting, the main purpose of this subnetting, the we are reducing the wastage of IP addresses, and one of the big network, whichever you can assume this one is the large network. Apart from that, we have more than large networks, like we have this many host. This is a host. If you need 1 lakh, if you need 1 lakh I host, then you can use this one. If you need 1 lakh host, then you can use this one. And if you need 10,000, or if you need 10,000 IP addresses, then we have this one, class B. And if you need only more than 100 IP addresses, then you have class C. We are one of the large network, we are dividing to the smaller part. So that is the main concept of subnetting. So now move to the how we are implement the subnet. So we have two types. One is fixed length subnet mask and variable length subnet mask. I'm giving you here example of like fixed length. We'll do some example. We required some 50 host or 30 host, whichever our basis of we'll do the lab. Now I'm taking here my requirement is 40 host. So we have here step by step formulas. So we'll do now those things. So basically, if requirement is 40, the requirement is 40. So first, in step one, how much required host bits? Host, it means end users. How many end users are available? Means one HR department is there. In HR department, how many employees are working? How many employees are working? We'll take those employees here, the end users likewise. We'll assigning each and every PC one IP address. If you have here 40 host in HR department and account department 40, some different departments are there, sales department 40. Likewise, we'll take the examples. Now requirement is 40. So if I want to take a requirement as a 40, so where it will be matched. First of all, we should have to take a value. So in this case, where it will be matched. So here the 40 will match here 2 to the power of 6. 2 to the power of 6. Now our host bit is here 6. Required host is required host is 40. So the value is here sixty-four. It the value will come. So the value it will be greater than or equal to that will match, value will match greater than or equals to 40. So the value is matching here. So now move to the converted. Step 2 is converted network bits. In the converted network bits, total host bits minus required host bits. Total host bits is here n is equals to total host bits are here 8 minus required host bits are 6. Means totally host bits means you can assume like the value it will be, it comes under a dot a dot 8 and 0 0 0 0. It's a actually class C value. This is a network bit and this one is network bit and this one is network bit. This one is the host bit. So this one is 8 plus 8 and 8. Here host bits are empty but 8. That is what I have taken. Total host bits are 8. Total host bits are 8. And how much required is here? 2 to the power of 6. So minus the total required host is that much, that is n. Now coming to the step 3, total network bits. I need of now total network bits. So for the total network bits, step 3, total network bits for total networks plus converted bits. Here total networks are like here actually 8 plus 8 plus 8. That is 8 plus, these are the total network bits. 8 plus 8. 16 plus 8. 16 plus 8, 24. 24 here, whichever we have the bits, which what we got here, converted bits are 2. This one is the converted bits, that is 26. It says slash value. Like this one is that yours subnet mask also. This is subnet mask also. Now subnet mask of this one is like 8 plus 8 plus 8 plus here 2. So subnet mask is 128 plus 64. So it will be subnet mask is 192. So subnet mask is for this 255 dot 255 dot 255 dot 192. This is a subnet mask also. And subnets, how many subnets we have here? 2 to the power of n. N value is 2. Total subnets are here 2 to the power of n. So 2 power 2 is equals to 4. We have the block size, that is say block size here. This many 4 blocks we have. It means the value will be start from 0 to 63 and 64 to 127 and 128 to 191 and 191 to 192 to 55. This is the block size. So here we have 4 blocks. Now move to the how in this block how many ranges are there? Block IP addresses means in this block how many IP addresses are there? So that is actually 64 IP addresses. How we got this? 2 power 6, that is 64. Now move to the valid IP addresses. Valid IP addresses is 2 power h minus 2 is equals to 62. Means here the value actually 64 minus 2. We got a valid IP address. So our IP address range is start from 192, 168 and 50.1 to 192, 168, 50.63. This is a broadcast IP address. In first one is the network bit is 0. The bit will be start from here and end will be here. In between, whichever the IP addresses are there, that is 62 IP addresses. This is all about subnetting. Thank you for watching the video.